Okay, I put the chamfer on the bottom of this. It's about 8 degrees, 8.5 or so. That should make it so that when the boat heels, this disc hits the water, with the front will be 5 degrees up, but horizontally it'll be relatively flat. I pre-drilled holes here, so I'm just going to reattach this. Okay, so one thing that somebody pointed out was that they said that I have taken a simple boat and made it complicated, and I agree with you. It probably, for the punt, it probably could have used a smaller sail and no outrigger at all. But since I made the sail as big as it is, now it's more about testing the sail, and I have to have some kind of outrigger, and none of the other outriggers that I have would have worked, so I had to build this. And I get to test this. It's a new concept. Well, it's not really new because I could have put a hydrofoil on the bottom and that would have been basically the same thing. The major difference is there's no drag from the hydrofoil or the hydroplaning disc at low speed. So what you want is you want the buoyancy part to do all the work when the boat is just sitting around, bouncing around at low speed. When you just you want the buoyancy float to do all the work at low speed because the dynamic lift doesn't work at between 0 and about 5 knots. But because I'm taking advantage of the natural heeling action of the sail, the outrigger will get deeper in the water. It's undersized because it doesn't have to be equal in buoyancy to the whole weight of the boat, like a 150% float on a trimaran. I don't really need that. What I need is a float that's just big enough so that the disc doesn't make contact until the boat is going about 5 knots, and at that speed the disc will create lift. So yesterday I said that the disc lift would equal the float, but that's only at a certain speed. If I can continue to accelerate, the disc will keep pace with the heeling of the sail, and the boat will just keep accelerating as opposed to heeling more. So the disc, in theory, should not go underwater ever, unless there's a wave, and that would only be temporary. So yes, I agree, it is overly complicated for a small punt. And so as you can see, it's going to be leaning up, and it's going to be tilting. It's 8 degrees that way, and if you look here, it's 5 degrees the other way. So the disc will create lift at 5 degrees. 5 degrees is actually a very good angle for hydroplaning lift. The ideal angle is about 4.5 degrees, but you can go up to about 6 degrees of incline before the drag starts becoming a factor. If you go above 6 degrees and you go like to 8 degrees, then all the benefit that you get from the increased lift is basically destroyed by the increase in drag. So that's why the angle of attack is very important. You don't want it too shallow and you don't want it too steep. 5 or 6 degrees I've found is the ideal angle. So why am I doing this? Well, one of the things that you want to avoid when you're designing a boat is the creation of waves. When you create a wave, you're dispersing and wasting energy. So what happens is the water will hit here and it will shoot up like this, it'll catch this and it'll deflect back down. And this disc will create lift. And even if the water level is like here, and then as the water level rises, most of the spray will still be hitting the bottom side as opposed to going over the top. And actually, maybe an improved design would have this extend a little bit further forward so that all the spray goes down. Now the only thing I have to worry about drag-wise is right in this corner. I have to put a really nice big fillet in here because that's going to be very draggy. And if you put a big round fillet in there, it'll reduce the drag a whole lot. There's the installation of the outrigger and float and my new lee board. As you can see, it's angled up 5 degrees on this plane so that the disc hits the water at a positive angle of incidence. And it's tilted about 8 degrees in this plane. So the line from the disc should go right through the center of the top of the center of the top of the water line, basically, of the hull. That's about right. I really don't think this boat is going to flip over now, unless I get, you know, something like 20 knots or something. So I'm pretty confident this is going to work.